Hi everyone, this is Nicole with Titans of CNC Academy, and in this video I'm going to show you how to program the TITAN-1M for the TORMACH and other low horsepower machines. Now before we begin, I do want to say the purpose of this tutorial is to provide you a good solid baseline to use on your TORMACH. These are not meant to be production speeds, it's not in any way fast or aggressive, but it's a good safe starting point, and from there you can increase your speeds, you can increase your step over as you see fit. So the first thing we do when we're programming our part is we need to set up our stock. So to do that, I'm going to come up to this tab Setup, and I'm going to drop it down, and you can see some options here. I'm going to choose New Setup. So you can see the parameters that we have here. Obviously, the operation type is going to be set to milling. We need to change our orientation. You can see when I select it, right now it defaults to model orientation. We have a few options here. So we can select our X and Y, we can select our Z and Y, or we can select our Z and X, and so on and so forth. So I'm going to use select Z and X axis. So now you can see here it wants us to choose our Z axis. So I'm just going to use this top face to set that. And now it's asking for our X, and I'm going to use this back edge here. So you can see here that we have some options. We can flip the Z axis or flip the X axis. I can actually see that my origin is already facing the correct direction. You can see Y is going to be facing the back of the machine and Z is going to be facing up. That's how I want it to be. So the next thing I need to do is we're going to change our origin. Now, we know that when we're setting up our part in the vise, that this back edge is going to be against the fixed jaw in our vise. And this edge will probably have a stop on so that we can always put the part back in the same place in case we need to make more of these. So I know I'm going to choose this side and this side as our origin, and I know the top of our model is going to be our Z origin. So I'm going to select our origin here. Right now it defaults to stock box point. I don't want it on that. I want it on model box point. This way we can base everything off of an edge on the model and not on the rough stock. So now it's asking me to choose a point to select our origin. So since I want this face and this top face to be our origin, I'm going to choose the intersecting point, and that's going to be this back left edge. All right, that looks perfect. So the next thing we need to do is go into our stock tab. Now you can see here we have mode. You can choose a few different options here. We have fixed size box, relative size box, cylinders, tubes, everything else. We want to choose relative size box for this. For our stock offset mode, we like to choose add stock to all sides. This way we can control all of the different parameters available. So looking at our current dimensions here, we can see our part size is 4 inches by 1.9 by 0.75. So I know my stock size that I'm going to be using in the machine is 4.1 inches wide by 2 inches by 1 inch. Now, it's very important for you to measure your actual stock size so that we can program it exact, especially on lower horsepower machines, because if, for example, we put in a stock size in our program that's smaller than our actual stock size, the tool is going to sound fine on one side, our origin side, but when it comes around to the off side, it's going to be taking a much bigger cut, and we definitely don't want that. So always double check, especially your width and your depth. You want to make sure that those are spot on. So since my stock size is 4.1, we know the difference is 0.1. Now I want to add that 0.1 evenly on both sides, so I'm going to divide it in half, and that's going to give me 0.05 for our negative X and 0.05 for our positive X. And now you can see it added the stock evenly on both sides. So I'm going to be doing the same thing for Y. It's 1.9. The difference with my stock size is 0.1. I'm going to split that in half, giving me 0.05. So now you can see our width is correct, 4.1. Our depth is correct, 2 inches. And now our height is all that's left to do. So the same rule applies here. I know that my stock size is 1 inch. I know that I'm going to be adding some stock to the top so that we can clean this up and make it a nice, clean face. So I'm going to add 0.02 to the top. So I know the difference here is 0.25 minus that 0.02. That gives us 0.23 for our negative. And then I'll add that 0.02 in our positive. And that makes a total height of 1 inch. So that looks perfect. Always make sure to double check your stock size, and say your stock is a little bit bigger than mine, adjust it accordingly in your program. All right, so I'm going to go ahead and click OK. And now looking at our part, I know the next thing we want to start on is establishing this top face. So to do that, I'm going to basically be planing this top surface, and then we'll do everything else from there. So to do that, we're going to come up to 2D and down to face. And now you can see the parameters that it gives us. We need to start by selecting our tool. So I'm going to come up to select. I'm going to come to the Titan building blocks library. The tool we're going to be using is a face mill. You can see that in the library we already have a 3-inch face mill, but for the TORMACH we're going to be using a 1.5-inch diameter steel rim shell mill from Kennametal, and we're going to be using a 1/2-inch TTS shell mill arbor from TORMACH with that tool. So we want to start by coming up to New Mill Tool. And you can see it gives us several options here. So we want to start by changing the type of tool we're going to be using. So you can see there's lots of different tools to choose from. We want to select the face mill. So the number of flutes is actually 3 for the tool we're going to be using. So I'm going to go ahead and leave that in there. Basically, anytime you're creating a tool, you can just kind of measure whatever parameters it's asking for and input that info. For this shell mill, I know that the diameter is 1.5. I know that our flute length is 0.63. Our shoulder length is 0.75. Our shaft diameter, I'm just going to put in 1.5. Our body length is going to be 1.575. And I can go ahead and leave that overall length in there. That all looks good. You can see we have some tabs at the top. I don't really need to mess with any of these. We can go ahead and go to the general and give it a name. I'm just going to call it 1.5-inch shell mill. And then I can go ahead and click OK. So now that we have that tool highlighted, I'm going to go ahead and click OK. And now you can see we have that tool in there. So for our spindle speed, I'm going to be running this at 4,000 RPM. The reason for this is because most low horsepower machines can handle doing 4,000 RPM. The 770M Plus machine that we're going to be running this tutorial on has a spindle max of 10,000 RPM. But for example, my older 1100 at home can only do 5,100. As you can see, 4,000 would be a great middle of the road for all different machines. So we're going to set those to 4,000. Our cutting feed rate, I'm going to set this to 20 inches per minute. That's how fast the tool is going to be moving in the cut. Our lead in and lead out, I'm also going to do 20. This is going to control how fast the tool enters the cut and how fast it leads out of the cut. So for our ramp and our plunge, we're not really going to be doing any ramping or plunging into material here. We're going to be working off the part and then taking a cut. So I'm just going to go ahead and set those to 20 as well, since we don't really need them. In our geometry tab, I don't really need to select anything for this facing operation. We're not going to be setting up any boundaries for the part to stay in different areas, so we're just going to go ahead and leave that all to default. In our heights tab, I want to start by setting everything to model top. And the reason for this is so that everything's consistent and we know where everything is based off of. It makes it a lot easier to kind of figure out where the tool should be when we're running it on the machine. So as you can see, our clearance height, which is the first height that the tool is going to enter when it rapids down, is going to be 0.4 above this surface on our model, the top surface. Our retract height, which is where the tool is going to come up to when it needs to move over to another tool path or another section of the part, that's going to be 0.2 above this top surface. Our feed height is going to be at that same height, 0.2. We could even drop it down to 0.1. I'm just going to leave it defaulted to 0.2. And our top height is this top surface. That's where the cut is going to be starting, and our bottom height is going to be that same surface. So that's where the cut is going down to. In our passes tab, you can see we have some parameters here that we need to fill out. So our tolerance is fine. Our pass direction, basically if I leave that set to 0, it's going to start the tool on the right side and it's going to come across this way. I want it to start on our origin side. This way I know exactly where the tool is going to be entering on the part. This is the side that we're going to be setting up our stock on. It'll just make it a lot easier to proof out this program. So I'm going to set my pass direction to 180 degrees. This will switch it from this side over to this side. For our pass extension, so I know that if I leave that set to 0, the center of our tool is going to start on this first edge and it's going to end right on the center of this trailing edge. So I don't want it to do that. I want it to start off the part quite a ways and I want it to end off the part. So we need to add in a pass extension. Since I know that our tool is 1.5 inches in diameter, and I know that it would normally start on the center of the tool for this tool path, I want to offset it half of the tool. So half of the tool is 0.75, but I want to go past that even just a little bit. I'm going to do 0.76. So for our stock offset, I don't need to add anything in there. That would be if I wanted it to take additional passes starting off the part in Y. But since I don't need it to do that, I'm just going to have it take 2 passes along X, and that'll be perfect. So for our step over, I'm going to set that to 1.4. Our tool diameter is 1.5, so this will leave a little bit of overlap between our passes, and that'll blend nicely. For our direction, right now if I have it set to both ways, if I were to do that, it would start a cut on this side and it would come across and then it would take the next cut on the opposite direction. I don't want it to do that. I want it to start the cuts from the same side. So I'm going to set that direction to climb. This will ensure that the tool starts on the same side for each cut. Next, in our linking tab, I don't really need to mess with anything in here. The defaults are fine for this tool path. I am going to turn off our lead in and lead out. This way the tool just comes straight down and over, and since we're plunging off the material, I don't really need any kind of lead in radius or lead out. So I'm going to go ahead and click OK. All right, perfect. So you can see with that pass extension in there, it's definitely starting off the part. It's going to drop down. It's going to come across the part surface. It's then going to lift up, and you can see where we have that retract height in there. It's going to come up over the part, and then it's going to drop back down and take its second cut from the same side. Now we've established the top face of our part. Now the next thing we need to do is start roughing out the basic shape of our part. So the easiest way to do that would be to use a 3D adaptive toolpath. This will allow the computer to figure out a way to get rid of the bulk of the material so that we can come in afterwards with more strategic toolpaths to finish our part. But before we do that, I want to look at our part and kind of determine what size tool we want to use. So the way we decide what size tool we're going to use when we're roughing out and finishing our part is to kind of inspect it and take a look at it. So we can see that we have these radiuses here on our part. So I'm going to choose inspect and we're going to look at those. So we know that the radius is 0.195. And you can see here it even shows the diameter 0.39. So I know that I need a tool that's smaller than 0.39 in order to get into that radius. but I want to use the biggest tool I can. So the closest size up to this radius is going to be a 3/8 tool. So that's what we're going to use. So just keep that in mind when you're programming. Always kind of take into account what is the smallest radius and what is the biggest size tool I can use to get into that radius. So I'm going to go ahead and close this. So the first thing we want to do is come up to 3D and down to adaptive clearing. We want to choose our tool from the library. So we're going to be using the 3/8 inch flat end mill. So I want to change our spindle speed to 4,000 RPM. And for our cutting feed rate, I'm going to set that to 20 inches per minute. So that's going to be how fast the tool is going to be moving in the cut. Our lead in and lead out, I'm going to go ahead and set to 20 as well. For our ramp and our plunge, I know that we are going to be ramping down into this pocket, so I definitely want to slow that down. I'm just going to do 15 inches per minute. That should be a good safe number to ramp down into this part. And I'm going to go ahead and set our plunge to 15 as well. In our geometry tab, I don't really need to select anything. We do have rest machining checked. This is because we already started cutting our part, so now it's going to take into account that when it's creating the toolpath. In our heights tab, I'm going to once again set everything to model top. So you can see our clearance height is going to be 0.4 above the top of the part. Our retract height is going to be set to 0.2 above the top of our part. Our top height is going to be the top surface of our model. And our bottom height is going to be based from the top of the model. And we know that our part is 0.75 tall. And we want to go actually a little bit below that. And the reason for this is when we flip the part over to finish that backside, it'll give us a little bit more wiggle room and make a nice, clean, finished part. So I'm going to go down negative 0.77, and that gets us a whole 20 thou below our part, which should give us plenty of room on the other side to finish this part. In our passes tab, I don't really need to mess with the tolerance. That should be fine. There's no shallow areas to machine on this part, so I'm going to leave that unchecked. Our optimal load is essentially what step over we would like the tool to maintain. I'm going to set that to 0.015. I don't need to check both ways. Our minimum cutting radius, which is how small of a radius we're willing to let the toolpath make, I'm going to set that to something a little smaller. I'm going to do 0.015. I do want machine cavities checked. This will allow it to get into this pocket and machine this cavity. I don't need to use slot clearing in this particular case, so I'm going to leave that alone. I definitely want our direction set to climb. Basically, if you're unsure whether your tool is going to be climb cutting or conventional cutting, you can picture it like when the tool is turning. Is it climbing up the surface, or is it going kind of against the rotation of the tool? And we definitely want it set to that. For our maximum roughing step down, this is the max we are wanting the tool to drop down to take a cut. I want it to go full depth. I don't want it to take any multiple depth cuts. So I'm just going to put 0.8, which is definitely bigger than the part size, so I know that it'll take it all in one pass. Our fine step down is fine at 0.08, and I do want to check the box that says flat area detection. This will allow the computer to detect these flat areas and machine them at that level. And the minimum step down for that is 8 thou. That is perfectly fine with me. So for our stock to leave, which is how much material it's going to leave on the sidewalls and on the bottom of our part for our next tool to clean up, I'm going to set that to 5 thou. That'll give our next tool a nice light cut to finish the part. In our linking tab, you can see we have retraction policy. Normally I would set that to minimum retraction, but in this case there aren't really any multiple levels that this has to machine. But what that does is when you set it to minimum retraction, rather than doing a full retract to another level, it's going to just do whatever the minimum required to get to that level is. But I can go ahead and leave that. For our maximum stay down, This basically controls how far we want to allow the tool to travel after taking a cut before it does a retract to take the next cut. So we want it just to stay down on that surface. I know that it's not going to travel any more than probably 1.5 inches. So it's not going to be trying to retract anyway. So I'm sure that 1.875 is fine in this case. For our stay down level, we want to set that to 70%. This basically determines how much the tool is allowed to lift to go over obstacles or around obstacles. So we want it to stay down much of the time. If it needs to come around the part, it's going to do that rather than lifting and coming over. For our no engagement feed rate, so this is any time it is not in a cut, but it's down at the cutting level, how fast it's going to be moving. I'm just going to bump that up to 90 inches per minute. You can do less if you're unsure, but the faster that number is, the better. It'll save us some time, and it's not cutting, so there's not really too much risk in bumping that up. So you see our lead in and lead out radiuses here. We have the horizontal lead in radius, which is the radius at which the tool is traveling toward the cut. I'm going to make that a little bigger. I'm going to put that at 0.15. That way you'll see that nice radius as it comes in. You can see the vertical also is 0.15, so as it's coming down, it's going to have that vertical radius as well. This will help the tool blend into the part rather than just coming straight over and entering the cut. So you can see we have our ramp type here, and you can see the couple options. We have pre-drill, we have plunge, we have helix. I'm going to choose helix because I know to get into this pocket, we need to kind of ramp down in a spiral to get to the bottom, and then we can start working from there. So you can see the ramping angle right now it defaults at 2 degrees. I'm going to set that at 1 degree. That's going to be a nice light angle as it comes down in that spiral. So I'm also going to add a ramp taper angle. What this is basically going to do is as the tool ramps down in a spiral, the diameter of that spiral is going to get smaller and smaller. This will keep the tool off of the side walls of the cut, which will help the chips have somewhere to go, and also it'll prevent the tool from chattering against those walls. So I'm going to add a 1 degree ramp taper angle. Our ramp clearance height is fine at 0.1. Our helical ramp diameter, I'm going to put that at 0.35. And our minimum ramp diameter, I'm going to put at 0.3. Now I'm going to go ahead and click OK. Okay, so you can see how the tool is going to drop down here. You can see that big lead-in radius that we've got. It's going to come around the outside of our part, roughing out that outer profile. It's then going to lift, coming up over the part, and you can see our lead-in radius there. It's going to start taking cuts, and you can see since we told it to stay down even when it's not cutting, it's just going to keep looping back and taking cuts and looping back down at that level rather than lifting each time. It's then going to lift and come over, and you can see where it's going to start that ramp. You can see that 1 degree angle that we put in there. It's nice and light. You can also see how it kind of tapers down almost like a cone. The shape of this, it kind of comes down to a smaller size at the bottom. This will really help with chips evacuating out and also keeping that tool from chattering around in there. It's then going to start working its way out, roughing out our part, opening up this whole pocket. now that we've established that top face and we've roughed out the basic shape of our part, we need to start doing some finishing tool paths. So we're going to start with this outer profile. The best way to do this is to use a 2D contour. So we're going to come up to 2D, we're going to drop down to 2D contour, and I'm going to be using that same 3/8 flat end mill to do this. We can actually slow down our cutting feed rate. 20 is probably okay for finishing, but I'm going to go ahead and do 15 in our geometry tab. So this is where we need to start selecting some contours. So we know that we're going to be finishing just the outer profile of our part. So what I'm going to do is I'm going to select the bottom edge of our part. So you can see it's going to just walk all the way around the outside, and that's exactly what we want. So I don't need to really select anything else in geometry. I'm not going to be confining the tool to any specific areas. We want it to finish this whole profile. So I'm going to leave everything else in here to default. And in our heights tab, I want to change everything to model top once again. All right, so you can see our clearance heights, 0.4 above the top, retract height, 0.2, feed height, 0.2. Our top height is going to be the top surface of our part, which is why the offset is set to 0. And our bottom height is going to be based from the top of the model. Again, we know that our height is 0.75, so I'm going to go a little past that. We're going to go negative 0.77. In our passes tab, we want to make sure our sideways compensation is set to left or climb milling. That way the tool is climbing up the side of the part. In our compensation type, you can see we have a few options here. When we're doing a finishing toolpath, typically we're going to want to have wear turned on. So I'm going to set that to wear. This will allow us in the machine controller to actually set tool diameter compensation right on the machine, allowing me to kind of control that finish size. So basically when it's done with this tool path, we're going to be checking it with calipers to make sure that the size of the part is correct. And if it's, say, a little too big, we can always just compensate by adding that compensation to our tool. So you can see they have the compensation radius limit in here. That's basically going to allow us to control how much we're willing to let the operator compensate that tool. So right now it defaults at 0.01875. I'm going to go ahead and just leave that in there. There's no way we're ever going to need to compensate it more than that. The make sharp corners, I don't need to check that. This is an external tool path. It's not going to be putting the tool into any corner, so I'm just going to leave that. Our minimum cutting radius, again, since this is an external toolpath, I'm not going to mess with that. For multiple finishing passes, I don't need to check that. We're only going to be taking 5 thou off of this, so I'm going to go ahead and leave that. Our finished feed rate, 15 inches per minute is what we want, so that's great. Repeat finishing pass, that might be necessary in certain materials, but for the aluminum that we're going to be cutting this with, I'm not even going to check that. Our finish overlap, I'm actually going to add a 10 thou finish overlap. This will prevent the tool from leaving any witness marks, and it'll just be a nicer, clean finish where the tool is going to lead in and lead out. I don't really need to mess with anything else in here. I can leave it all to default. Most of this is going to be if we were doing like roughing passes or anything like that, but I'm going to go ahead and leave everything. In our linking tab, I don't really need to mess with anything in here. That looks good. For our horizontal lead-in radius, I'm fine with 0.0375. That should be a good radius as it's coming in. Again, it's just finishing the outside, so that should be fine. Our lead-in sweep angle, I can actually go ahead and change that to 45. So instead of coming straight at the part, it'll come kind of at an angle, and then it'll enter that radius. Our linear lead-in distance, I'm going to go ahead and leave that at 0.0375, and our vertical lead-in radius, I'm going to set that to 0. We don't really need it. It's just going to come straight down, over, and start to lead in. So I'm going to go ahead and click OK. So you can see where the tool is going to drop down here. You can see since we don't have that vertical lead-in radius, it's just going to come straight down to that linear lead-in distance, and then it's got that horizontal lead-in radius there as it comes around our part. It's going to finish that outer profile, and then it's going to pop back up right there. now we've established our top face, we've roughed out our part, and we've finished the outer profile. So now we need to finish this inner pocket and this step here. So we're going to do them both in the same tool path. We could do it with like a 2D contour and do multiple step overs, but I think the easiest and most efficient way to do this would just to be a 2D pocket. So I'm going to come up to 2D and we're going to select 2D pocket. We're going to use that same end mill, same feeds and speeds. I'm going to go to our geometry tab and you can see where it asks for a pocket selection. So we want to choose this pocket in here. So you can just select the contour of the pocket. Rather than trying to select the contour, which might give you issues, I'm just going to select the bottom face of it. So now that we have our pocket selections, I'm going to come up to our heights tab. And in here, I want to change everything to model top as usual. But this time for our bottom height, I'm actually going to choose selection because we want to make sure it's set on this face. And as you can see, it adds it in there. So you see our bottom is -0.5 below the top surface. That looks great. And we've got our clearance set to 0.4, our retract 0.2, our feed height is also 0.2, and our top height is 0. So that's exactly what we want. That looks really good. In our passes tab, we want to again make sure our sideways compensation is set to climb milling. This time for our maximum step over, we're going to do 0.25. The reason why we're able to do such a bigger step over for this is because we're only doing a 5 thou depth of cut. And our radial cut is also only going to be 5 thou. So it's such a small amount, the 0.25 step over will not mess with us at all. I want to make sure that our stock to leave is turned off since this is a finishing toolpath. Next, in our linking tab, I don't really need to mess with any of these parameters here. We can leave all that alone. For our horizontal lead-in radius, I'm going to go ahead and leave that to default. The linear and the vertical are fine as well. For our lead-in sweep angle, I'm going to go ahead and change that to 45 so it kind of comes in more at an angle. For our ramp type, in this particular case, again, since we're just taking a tiny amount, I mean, you're only talking 5 thou, I'm just going to drop it straight down into that pocket and we're going to use plunge. The ramp clearance height is fine at 0.1. I'm going to go ahead and click OK. Perfect. So you can see where the tool drops down here. You can see that vertical lead-in radius as it leads into the cut. You can see it comes around and takes a second pass. It's going to come up and over and it's going to drop down right here in the center of this pocket. You can see how it leads into the cut and it's going to loop around, taking out that center. It's then going to come over and down on this side, doing the same thing. Once it finishes this cut, it's going to lead out to the next cut, and it's just going to keep doing that until this pocket is finished. So we've finished our top face, we've finished the outer profile of our part, and we finished the pocket and the step. So the next thing we need to do is start putting chamfers on this part. So looking ahead, I know that we're going to be using a chamfer to spot drill these holes and add the chamfer. So I want to make sure the size is something that we can use to do both our chamfers and our spot drilling. So I'm going to be using a 1/4 inch chamfer mill. So we're going to come up to 2D and down to chamfer. I'm going to be selecting that tool from our library. We're looking for that 1/4 inch chamfer mill. So we're going to be running that at 4,000 RPM and 20 inches per minute on our feed rate. I'm going to go ahead and change all of these to 20 since they don't really matter. In our geometry tab, you can see it's asking for us to select the contour. So in this case, with the part I have here, I don't actually have chamfers modeled into my part. So I'm just going to select these top edges of our part. If there were chamfers modeled in, I would want to make sure that I select the top contour of the chamfer. So now that I have those selected, I'm going to move on to our heights tab. In here, I want to make sure I change everything to model top as usual. So for a chamfer, our top height and bottom height are going to be on the same surface, so I don't need to mess with any offsets in here. In our passes tab, I want to make sure that we set our compensation type to wear. That way we can control the size of our chamfer right on the machine. So since I do not have a chamfer modeled into this part, I want to make sure my chamfer width is set to 0.01, which is what is called out on the print. If the chamfer was modeled into this part, I would make sure my chamfer width is set to 0 and let the computer calculate the width instead. Our chamfer tip offset, I'm going to go ahead and set that to 0.05. We don't want the tip of the tool right on the edge of the part. I want to make sure that that's always kind of a bigger number than my chamfer width if I can. For our chamfer clearance, since I know for these two top chamfers, there's nothing really I'm at risk of colliding with, I'm going to set that chamfer clearance to 0. Next, in our linking tab, I'm going to go ahead and add a horizontal lead-in radius. I'm just going to do the same 0.025. And I don't really need to mess with anything else in here. I'm going to go ahead and just click OK. Perfect, so you can see where the tool is going to drop down here. We've got our vertical lead-in radius, linear lead-in distance, and then our horizontal lead-in radius. The tool is going to come around, putting that chamfer on our part, and then it's going to come up and over our part, dropping down here. And you can see how we've got that chamfer tip offset in there. So it's not going to be right down. The tip of the tool is going to be down here. It's not going to be right on that edge. So the next thing we need to do is add a chamfer onto this edge here. So to do that, I'm actually going to duplicate that last toolpath since it's already got quite a few parameters in that I would like to keep. So I'm going to right click, duplicate, and then I'm going to right click the new one and click edit. So our feeds and speeds are all going to be the same, so I'm going to leave that alone. In our geometry tab, I want to remove our current contour selection, and I'm just going to select this edge that we want to put a chamfer on. In our heights tab, the only thing I need to really change in here, everything can stay model top except for our bottom height. I'm going to change our bottom height to selection, and I'm just going to choose the face where we selected our edge. In our passes tab, our compensation type is already set to wear, which is what I want. Our chamfer width is already set to 10 thou, which I want since I don't have the chamfer modeled in. Our chamfer tip offset is already in there, but this time you can see how this edge kind of contacts this radius. If we were to leave our chamfer clearance set to 0, the tool would actually collide into this radius here on our part. So I'm going to add a 0.05 chamfer clearance, and that should start the tool away from this radius. In our linking tab, I don't really need to change anything. I'm going to go ahead and leave those and click OK. Alright, so you can see the tool dropping down right here. Got our lead in, got our radius, it's coming around. You can see the tool is definitely starting plenty far away from this radius. There should be no risk of it hitting. It's going to come across, putting that chamfer on there, and then it's going to come up. So the next thing we need to do is spot drill our holes. So not only are we going to be spot drilling, we're also going to be adding a chamfer to these holes before we even drill them. So the way we're going to spot drill them is by coming up to drilling and choosing drill. We're going to be using that same 1/4 inch chamfer, and I'm going to be running that at 4,000 RPM with 20 inch per minute plunge feed rate. I'm going to set our retract to 20 inches per minute as well. And in our geometry tab, I want to make sure we see it defaults to hole mode is selected faces. That's what I want it on. I'm going to select one of our hole faces. And instead of having to select each one, a cool trick when we have a lot of holes that are the same size is I can select the box that says select same diameter. This will choose all of the holes for us so we don't have to select them all by hand. I don't need to select anything else in here. I can leave everything else to default. In our heights tab, I want to once again change everything to model top. So now that everything's set to model top, we need to decide our bottom height offset. Since we want this spot drill to add a chamfer on our holes, we have to take into account that our chamfer mill has a 45-degree tip. This means the diameter chamfer the tool is going to leave is equal to the depth we set times 2. So if I set my depth to 50 thou, the chamfer diameter is going to be 100 thou. If I set my depth to 100 thou, my chamfer diameter is going to be 200 thou. So it doubles. Since our thread call out is 1032, we know that the major is 0.19. And since we want about a 10% additional chamfer, which we're going to round up to 20 thou, the total would be 0.210 in diameter for our chamfer. So since I know that it doubles, I'm going to set my bottom height offset to negative 0.105. So you can see it leaves a nice chamfer around the edge right there of our holes. All right, that looks good. In our cycle tab, I'm going to go ahead and leave our cycle type to drilling rapid out, and we'll go ahead and click OK. So you can see where the tool comes down. You can see it's definitely going to leave a nice little chamfer around our hole. It's going to come up and over our part, doing each hole. Now we just need to drill and tap our holes. So since we already selected the geometry in the last toolpath, I'm actually just going to duplicate it. I'm going to right click, duplicate. This will just make it a little easier. I'm going to right click the new one and click edit. We're going to come up to our tool tab and we're going to select our tool from the library. This time we want to choose the 0.1772 drill. And we'll go ahead and leave our spindle speed to 4,000 RPM and our feed rate is 16 inches per minute. That looks good. Our geometry is already selected, so I don't need to mess with that. In our heights tab, everything's already set to model top, so the only thing I'm going to change in here is our bottom height offset. Now I know that the thread call out on our print is 0.380 minimum. So I want to make sure that we're going to be tapping past that depth. I want to make sure I even go deeper with my drill. So to give my tap extra room, I'm going to go negative 0.58. And that'll give our tap plenty of room to get down to that depth that's called out on our print. In our cycle tab, I'm going to change our cycle type to chip breaking with a partial retract. Chip breaking is great for lower horsepower machines, especially when you're drilling at depths greater than 2 to 3 times the diameter of the tool. So rather than doing a full retract that takes a lot longer, if we do a partial retract, the tool will be just taking short pecks and it won't be coming up all the way out of the hole. It'll just come up a little bit to pull those chips out, and then it'll descend back down into the cut. This will also prevent the tool from chattering a bunch as it's trying to come out of the hole. We're going to set our pecking depth to 0.05. Our pecking depth is how big of a cut it's going to take each peck. We're going to set our minimum pecking depth to 0.015. This is just the minimum allowed pecking depth. Our accumulated pecking depth is how far it'll go before it does a full retract. I don't want it to do any full retract. I just want it to do chip breaking all the way down. So I'm going to do 1 inch on that, which is well past our depth of cut. Our chip break distance is how far the tool is going to retract before it takes that next peck. So I'm going to do 10 thou on that. And then I'll click OK. Perfect. So you can see the tool is going to start over here. It's going to come up and over our part, drilling each of these holes. The last thing we need to do is tap our part. So to do that, I'm actually going to duplicate that last toolpath again. Right click, edit the new one. We're going to go up to our tool tab and I'm going to select the tool from the library. This time we're going to be using the 1032 tap. So I'm going to change my spindle speed. This one's kind of important. You'll want to double check with your machine. For the 770M Plus machine that I'm going to be running this part on, my minimum spindle speed in high gear, which is what I'm going to be using, is 525. So I'm going to make sure that I'm above that. If for whatever reason you plug in a number that's lower than your minimum spindle speed, it's going to default to whatever that minimum is, and that'll mess up your ratio for your surface speed versus your spindle speed. So I'm going to run mine at 550. Always make sure that's something you double check on those lower horsepower machines. Our geometry is already selected, so I don't need to do anything in there. In our heights tab, everything's already set to model top, which is perfect. Our bottom height offset though, I do want to change. So we know that our print calls out a minimum of 380 on the depth of our thread. So since there's going to be taper in our tap, I'm actually going to go even deeper than that just to make sure that we hit a nice clean thread all the way to that depth. So I'm going to go negative 0.45, and in our cycle tab, I'm going to change our cycle type to right tapping. And then I'm going to go ahead and click OK. So you can see the tool's going to drop down, it's going to lift, come over, drop down. The programming for this part is now complete. I hope you enjoyed this video. Thank you for watching.